Hey everybody, in this video we are going to cover the first part of section 7.3. So this will be part 1 of the section 7.3 video. Section 7.3 is called Trigonometric Functions and the Unit Circle. Question number 1 says, determine the point x, y, so the coordinate on the unit circle associated with each real number s. All right, so part A is s equals pi over 3. All right, so you look at your unit circle and you say, okay, at the angle pi over 3, the coordinate is 1/2 comma square root of 3 over 2. So that is the point on the unit circle associated with the real number pi over 3. All right, for part B, we're looking at the real number s equals negative 5 pi over 2. All right. To me, the easiest way to do this is to convert this to degrees. I think it's easier to visualize where that's at on the unit circle if it's in degrees. So I'm going to multiply by 180 degrees over pi. It's going to cancel my pi's. That gives me negative 5 times 180. Negative 5 times 180 is negative 900 over 2. All right, so negative 5 times 180 goes in the top. 2 times, there's nothing down here, so it's just 2 in the bottom. Negative 900 degrees over 2 is negative 450 degrees. All right, so let's take a look at our unit circle. We're going in the negative direction, so we're going to start here. We're going to go clockwise. All right, so if we went all the way around the unit circle, starting here, and we went all the way around, how far would that be? We started here, we went all the way around. That would be negative 360, right? Negative 360 degrees. All right, so let's see how much we would have left over. How much further do we need to go? All right, so we started with 450 degrees, or we were trying to go around negative 450. We went around 360. We got 90 degrees more that we need to travel. All right, so another 90 degrees, that would be 1/4 of the unit circle. So we would go right here. All right, that's another negative 90 degrees. Negative 360 plus negative 90 gives you negative 450. All right, so this is the coordinate on the unit circle. How did they refer to it? The point on the unit circle that corresponds to the angle negative 450 degrees. So that's just 0, negative 1. All right, then we have the point. We're asked to determine the point on the unit circle associated with the real number s equals 210 degrees. So back to the unit circle, 210 is right here. So that is negative square root of 3 over 2, comma, negative 1/2. Okay. Negative square root of 3 over 2, comma, negative 1/2. All right, number 2. Determine all real numbers s associated with the point negative square root of 3 over 2, comma, 1/2 on the unit circle. Write the exact radian answer in between 0 and 2 pi and indicate remaining answers by using n to represent any integer. Okay, so let's look for that point on the unit circle. Negative square root of 3 over 2, comma, 1/2. Negative square root of 3 over 2, 1/2. There it is. And they want us to tell the angle in radians, so that's 5 pi over 6. All right, so 5 pi over 6. Now we need to address this part here. It says indicate remaining answers by using n to represent any integer. All right, so what this means is that if you started here and you went all the way around the unit circle again, so if you started here and you went all the way around the unit circle, you would still, the coordinate here is not going to change. Now this angle will change because you're continuing to revolve around the unit circle, but your coordinate here is not going to change. It's going to remain in this very spot right here. So that means if we go around 2 pi or 4 pi, if we went around twice, or 6 pi, the point negative square root of 3 over 2 comma 1/2 will not change, but the angle will. So we need to account for that. So we would say we can indicate the remaining answers just by adding 2 pi times n, where n is any integer. All right, so again, if we continued to revolve around that unit circle, so if we started here, and then we continue to revolve around another 2 pi, that coordinate's going to remain the same, but the angle will change. It'll be 5 pi over 6 plus 2 pi. We could go around again. That would be 5 pi over 6 plus 4 pi. So we continue to revolve around the unit circle and still be in this same spot that's associated with that ordered pair, negative square root of 3 over 2 comma 1/2. Okay. Next thing we're going to talk about is reference angles. So reference angles are always between 0 degrees and 90 degrees. If you're in degrees, if you're in radians, it would be between 0 and pi over 2. So an example of a reference angle, I'm going to draw a little unit circle here. All right, so let's say that we had some angle. Maybe we have the angle 135 degrees. All right, so the reference angle for 135 degrees, it's found pretty easily. You just go to the terminal side of the angle. Remember, the terminal side is the ending side, so that would be right here. So this would be the terminal side. All right, so you go to the terminal side of the angle, and you're going to draw a line straight down to the x-axis, or the horizontal axis. So starting at the terminal side, we draw an angle straight down to the x-axis. Refocus here. All right, so the reference angle is going to be that tiny angle right there that is formed between the terminal side of the angle and the x-axis. Now, how could we find that? Well, pretty easily. We know that this is 180 degrees over here, just like on the unit circle. Let me just throw that in here. This is the unit circle, that horizontal axis on the left side, that's going to be 180 degrees. So you can easily figure out that if this is 180 and this terminal side right here represented 135 degrees, then you can just do 180 degrees minus 135 degrees. Let's see. 180 minus 135 is 45 degrees. Right, so the reference angle, often written in the following way, it's usually theta with a little apostrophe there, and we call it theta prime. Theta prime. So theta prime is typically how we refer to the reference angle. We would say theta prime is 45 degrees. All right, so let's do a couple of examples with some bigger numbers other than 135, because the larger the angle that you're working with, the more complicated, or yeah, I would say more complicated it is to find the reference angle. I think that's fair. So thing to remember, reference angles are always between 0 and 90 degrees, or if you're in radians, 0 and pi over 2. All right, so let's start with our first example, which is in radians. Theta equals 9 pi over 8. If you are given your starting angle in radians, then your reference angle should be in radians. Whereas down here, our starting angle was given in degrees, so your reference angle should be in degrees. So whatever you start with, whether it be radians or degrees, that's what your reference angle should be in. All right, so determine the reference angle. It says in radians. We'll do radians for this first one, degrees for the second one. Associated with the given angle, write the exact answer. Do not round. All right, and just an FYI, we know that this reference angle should either be between 0 degrees and 90 degrees or between 0 and pi over 2 if we're in radians, like on the first one. First thing you need to do is draw the angle. I find it easier to draw the angle when I am in degrees. So I like to start by converting this to degrees. I'm going to multiply by 180 degrees over pi. It's going to cancel out my pi's. All right, so let's see. 9 times 180 is 1620 degrees over 8. Let's see what that is. 1620 over 8 is 202.5. Okay. Now we're going to draw that on the unit circle. So draw yourself a little unit circle here. Okay. 202 degrees. That would be past 180. So it'd be a little bit past 180. So maybe like down here. All right. So here's my initial angle and my terminal side, or excuse me, my initial side. And this would be my terminal side down here, just a little bit past 180. All right, so again, that's 202.5 degrees. All right, and now I'm asked to find the reference angle. All right, so again, remember what I told you. You go to the terminal side of the angle, which is right here. All right, so go to the terminal side of the angle. I'm trying to find the highlighter so I can highlight that terminal side. All right, so go to the terminal side, draw a line straight up or down to the x-axis. In this case, it's up right here, straight up to the x-axis. And that tiny, tiny angle right there is the reference angle. All right, so we know that this is 180. We know that this is 202.5 degrees. All right, so what is the distance right here between 202.5 and 180? Well, we can find that pretty easily just by subtracting. So 202.5 minus 180. So that angle, well, I've typed in 1800. So 22.5 degrees. That's that tiny little angle right there. All right, so our reference angle, theta prime, is 22.5. Now that's great, but we were supposed to answer this in radians because our original angle was given in radians. So let's just convert this back over to radians by multiplying by pi over 180 degrees. All right, so here's my little trick for doing this easily. I'm going to pretend like this is over 1. All right, I'm going to do 22.5 divided by 180. All right, convert that to a fraction. That's pi over 8, or excuse me, 1 over 8. All right, so what I just did is I said, okay, 22.5 degrees, pi in the top, 180 in the bottom. I just put just the degree part in the calculator and converted that to a fraction. They said that was 1 over 8. Right, so that reduced to 1 pi over 8, which is the same thing as just pi over 8. All right, so there's my reference angle for part A. All right. Now let's look at part B. This one is always hard for me to draw, so I'm going to take my time with this one. So again, first step when you're finding the reference angle, my advice is to draw it first. So draw yourself a little unit circle. All right, this one's a negative angle, so we're going to start here. Here's our initial side, and we're going to go clockwise since this is a negative angle. All right, so starting with 0 degrees, this is negative 360. All right, let's see how much we have left. 655 minus 360, 295. So we're not going to revolve all the way around again. Let's see, we're going to go almost all the way around. Let's stop there. That's probably not perfect, but it's good enough for me. Better than I usually draw this. All right, so starting here, we went all the way around negative 360. So I said, okay, well, negative 655, I've already taken care of 360 degrees. Now I need to go around negative 295. So not a complete revolution around the unit circles, because that would be another 360. So I knew that this would be 90, 180, 270. So I know I'm passing this side, and then just a little bit further. Okay, so let's think about what that what this would look like. We know this is negative 655 degrees. If we went all the way around the unit circle twice, that would be negative 720, right? Because it's 360 plus 360. So let's find the reference angle here. Remember, we go to the terminal side, that's here. Draw a line straight up or down to the x-axis, down in this case, right? And the reference angle is that tiny angle right there. So what is the distance between negative 720 and 655? Let's see. Negative 720 minus negative 655. Right, 65 degrees. I think I had an extra negative in there. When I think about it, I just think like, you know, forget about the negatives. Just say 720 minus 655. That's 65 degrees. All right, so 65 degrees is that reference angle there. This one's named phi or phi, so this one's going to be phi prime instead of theta prime. Right, and that reference angle again is 65 degrees. And our original angle was given to us in degrees, so we know our answer should be in degrees. All right, so you always draw the angle, then it's the distance between the terminal side of the angle to the x-axis. You may go up like we did on this one, you may go down like we did on this one. Right here we have a little table that I felt like would help you for the test. So this might be something that you want to add to your little formula sheet. It says signs of the trig functions. In quadrant 1, all of the trig functions are positive and none of the trig functions are negative. Right? In quadrant 2, let's see, cosine is negative, which means secant is also negative, tangent is negative, and cotangent is also negative. So that leaves the two that are positive are sine and cosecant. In quadrant 3, let's see, sine and cosecant are negative, and cosine and secant, and the positive ones are tangent and cotangent. All right, and then in the fourth quadrant, let's see, cosine, secant are positive, everything else is negative. So that's sine, cosecant, tangent, and cotangent. All right, so if you're wondering how did I come up with this, what I was doing is I was just looking in each quadrant and I'm saying, okay, well, I remember that cosine represents my x value and sine represents my y value. All right, so here you can see my x and my y values are both positive. So that means cosine and sine are both going to be positive. And since tangent is just sine over cosine, that would be a positive number over a positive number, which is still positive. So I went through and did that for every quadrant. So here you can see cosine is negative, sine is positive. That means that tangent is going to be positive over negative, which is negative. All right, so I did that for every quadrant. All right, and then last question for this video, then we're going to do a part 2, is determine in which of the 4 quadrants the angle theta is located, given that cosine is positive and cotangent is negative. So cosine is greater than 0, cotangent is less than 0. So where is cosine positive but cotangent negative? Cosine positive, cotangent negative. That would be in quadrant 4, right? Cosine positive, cotangent negative. Right, so that would be quadrant 4. Okay, so that's all for this video. Come back for part 2 to see the rest of the section 7.3 video. Thanks.